In this session, we will discuss about mutual exclusion in distributed systems. Systems involving multiple processes are usually programmed using critical regions. Now, when a process has to read or update certain shared data structures, it first enters a critical region to achieve mutual exclusion, and then it ensures that no other process will enter the shared data structure at the same time. Now, in a single processor systems, critical regions are protected using semaphores and monitors. In this session, we will see how critical regions and mutual exclusions can be implemented in distributed systems. In this session, we will be discussing about the centralized algorithm, followed by distributed algorithm and token ring algorithm in part 2 and part 3. Starting with the centralized algorithm. Assuming that there are 4 processes in the distributed system, process 0, 1, 2 and 3. Now among these processes, the process with the highest network address will be chosen as the coordinator. So we will make an assumption in this case. We assume that the process 3 is having the highest network address among all the 4 processes. And then process 3 will be made as the coordinator. Now this coordinator, that is process 3, maintains a queue to keep a track of the processes requesting to enter the critical region. Let's assume that process 1 is asking the coordinator for permission to enter the critical region. So it is making a request from process 1 to process 3. Permission is granted to process 1 since no other process is making use of the critical region. So it sends an OK message to process 1. Meanwhile, process 2 is asking permission to enter the same critical region to the coordinator. Now in this case, what the coordinator does is it won't reply to the process, since P1 or the process 1 is already making use of the critical section. But it will maintain this information in the queue that process 2 has requested to enter the critical region. In this case, process 2 will be blocked and process 2 is waiting for a reply. Now process 1 wants to exit the critical region. So what the process 1 will do is it will send a release message to the coordinator. Now the coordinator, that is process 3, will check if there is any process in the queue, and if yes, it will allow it to enter the critical section. Now we know that process 2 was requesting to enter the critical section when process 1 was there in the critical section. 1 has already exited the critical section, and now the coordinator will pick up the process from the queue, that is process 2 right now, and send an OK message to process 2. So now process 2 will be in the critical section. So this is how mutual exclusion is achieved using the centralized algorithm in the distributed system. Now let's have a look at the advantages of centralized algorithm. So very obvious that this algorithm guarantees mutual exclusion. Now the coordinator will allow only one process to enter into the critical region at a time, and the others that are requesting access to the critical region will be placed in the queue. Next, requests are granted in the order in which they arrive. The main thing over here is that no process ever waits forever. That means there is no starvation. The scheme is also easy to implement. The centralized algorithm requires only 3 messages to use the critical region. First, it will make a request to the coordinator. Once the request is granted, it will make use of the critical section, and then release, make a request to the coordinator again to exit from the critical region, that is release from the critical section. So these are the advantages of the centralized algorithm. Let's have a look at the shortcomings of the centralized algorithm. The biggest problem is the coordinator is a single point of failure. So if the coordinator fails, the entire system will go down. Now if a process normally blocks after making a request, they cannot distinguish a dead coordinator from permission denied, since in both the cases no messages come back. We can see that when process 1 was using the critical section, process 2 had made a request to use the critical section. Now in this case, this particular coordinator did not give any response to the process. So now the process 2 does not know whether permission has been denied or there is some other problem with the coordinator. And in large systems, a single coordinator can become a bottleneck.